Hello friends, welcome to the video. It's me Umesh Mallik, and from today I will be giving the series of lecture videos in physics. And physics is very beautiful subject. If we go outside in the environment or in nature, then we will be able to observe several or varieties of the phenomena. For example, the flowing of the river, the wind, the rainbow. When two objects are rubbed with each other, then there is the production of heat. There are several phenomena. And behind all these phenomena, there is some simple basic rule. And the main goal of physics is to discover or find that simple basic rule which governs the phenomena. And for understanding the physics, the role of mathematics is very much, or we can say mathematics is the language of physics. If we have good knowledge in mathematics, then it will be easy for us to understand the physics in good way. And that's why I will discuss about the required mathematics here in this lecture. And one should have better knowledge in trigonometry, simple algebra, coordinate geometry, vector algebra, differential calculus and integral calculus to master or to understand physics in good way. That's why in this lecture I will be discussing about the mathematics sections that will be required. Here I will discuss about vector algebra, differential calculus and integral calculus only, because we have already studied the trigonometry, simple algebra and coordinate geometry in our school ages. That's why let's focus on study of scalars and vectors first. This is the very important topic to understand physics. Now let's talk about the topic scalar and vectors. There are certain physical quantities which are completely described with the help of numerical value alone, with unit specified, and no other things is required, only we need numerical value. One of the example of such kind of the physical quantity is mass, and it can be represented with the help of numerical value alone. For example, if one body has mass 5 kg, then this whole numerical value itself describe the physical quantity. And next, such physical quantity can be added by using simple algebraic rule. That means no extra type of the rule is required. By using simple addition rule of the algebra, we can add this type of the physical quantity. For example, suppose there are two bodies of masses 4 kg and 5 kg. The total mass of the two bodies can be obtained by applying addition rule of simple algebra. That means we can simply use the simple algebra rule of addition, and we can get the total mass of the composite system. Therefore, total mass of the composite system is equal to 4 kg plus 5 kg is equals to 9 kg. By using simple addition rule, we can get the total mass, and in this way we come to the conclusion that those physical quantities which are completely described with the numerical value alone, with unit specified, and can be added by using simple algebraic rule, are called scalars. And other examples of the scalars are time, distance, etc. Okay, now let's talk about the vectors. The complete description of certain physical quantities require numerical value as well as direction in space. If it's one of the example is velocity, to define velocity or to describe velocity, we require numerical value as well as direction. The magnitude of velocity is represented by the numerical value such as 10 meter per second. If you represent the magnitude of velocity as 10 meter per second, then it will tells us how fast the body is moving. But this numerical value do not give the information in which direction the body is moving. That means this numerical value only tells us how fast the body is moving, but it will not mention or specify in which direction the body is moving. So the description of the velocity becomes complete when the direction of the velocity is also specified. That's why the velocity is meaningful when there is both numerical value as well as direction in space, which specify or which shows the direction of the velocity. We can represent this velocity by drawing parallel line to the velocity and putting an arrow to show the direction of the velocity. That means we can represent the velocity. We can represent the velocity by drawing line and putting arrow. This line is drawn parallel to the direction of the velocity, and this arrow shows the direction of the velocity. And we can use the length of this line to show the magnitude of the velocity. For example, for 1 meter per second, this much length of the line is drawn, and for 5 meter per second, 5 times of this unit length is drawn. For 7 meter per second, 7 times of this unit length is drawn to show the magnitude of the velocity, and this arrow shows the direction of the velocity. This front end where arrow is drawn, this end is called the head, and the rear end is called the tail of the vector. Okay, now next thing is, if a particle is given two velocities at the same time, then the resultant velocity is different. If we give two velocities to a body, then there will be different resultant velocity to of the body. For example, let us take, there is one transparent tube, and inside this tube there is one small spherical ball. This ball moves in this direction along the tube with the velocity, suppose 3 meter per second, and at the same time the tube is also moving upward with the velocity 4 meter per second. That means this ball is moving inside the tube, along the tube with the velocity 3 meter per second, and tube itself is moving upward with the velocity 4 meter per second. At the time t is equals to 0, the tube is here. That's why at t is equals to 0 time, the spherical ball is here, and as the time is 1 second, if the time elapsed is 1 second, then the tube will be here and the ball will be reached here. If we see from the room frame, then we will get to observe this ball will be moved here, and this body will be seen or observed to move in this direction with this in this line. And simple mathematics tells us that this ball has moved 5 meter. That means this ball will move 5 meter per second. That means in 1 second the ball has moved 5 meter, and the direction in which the ball has moved is, simple mathematics tells, it will be 53 degree. Okay. The rule for finding or obtaining resultant velocity is, draw a line AB representing the first velocity. AB is the first velocity. This one is the first velocity. And draw another line BC representing the second velocity. This BC is second velocity. And draw another line BC representing the second velocity with its tail. Its tail BC, the tail of BC coincides with the head of first velocity. head of the first velocity. Then the line AC represents the resultant velocity with head at C and tail at A. That means here whole thing written is as draw a line AB representing first velocity and draw the line BC representing the second velocity, where the tail of second velocity coincides with the head of the first velocity. Then the resultant of the vector is then the line AC represents the resultant velocity with head at C and tail at A. Then we join A and C, and this AC will be the resultant vector, resultant velocity, where C is the head of the resultant velocity and A is the tail of the resultant velocity. The resultant velocity or the resultant of the vectors is also known as sum or the addition of the vectors. Now, those physical quantities which have magnitude and direction and which can be added using triangle rule are called vectors. That means we came to the conclusion that vectors are defined as those physical quantities which have both magnitude and direction and which can be added using triangle rule are called vectors. There are several examples of the vectors. For example, force, momentum, electric field, magnetic field, etc. There are many vectors. Vectors are represented with two letters, alphabetical letters with arrow at the head showing the direction from A to B, or with the help of single alphabetical letter with arrow at the head or at the up. And next point here is those physical quantity which have both magnitude and direction but do not add according to the triangle rule, then the quantities are not vectors. If a quantity has both magnitude and direction but do not add according to the triangle rule, then the quantities are not vectors. For example, electric current. Electric current has both magnitude and direction but do not add according to the triangle rule. Now let's talk about the equal vectors. Two vectors that represent same physical quantity are called equal if their magnitude as well as direction are same. That means if two vectors have same magnitude and same direction, then those vectors are called equal vectors. Therefore, from here, parallel translation of the vector does not bring any change in it. That means in parallel change also, if we parallelly slide the vector, then there will not be change in the direction and there will not be change in the magnitude. That's why parallel translation of the vector do not affect the vector. Now let's come to the addition of the vector. We have already somewhat talked about the triangle rule of vector addition. The triangle rule of the vector addition tells us if first vector is represented by A vector and second vector is represented by B vector, where the tail of the B vector coincides with the head of the A vector, then the sum of these two vectors will be given by the next vector in which the head of the sum coincides with the head of the B vector and the tail of the resultant vector coincides with the tail of the first vector. Now we will describe this, or we will learn, or we will get this point with the next idea. Here what I have done is I have slid this B vector from here to here. That means all the tail of the two vectors gets coincides with each other. Here the B vector is slided at the here AC vector represents the new vector. Here both the vectors tail coincide at the single point and will construct a parallelogram, will complete the parallelogram. Then the diagonal vector give the resultant of both of these two vectors. Now let us calculate the magnitude of the resultant vector. Let us suppose there are two vectors, AB, that is A vector, and BD, that is B vector. This AB and this BD vector is same as AC vector. This is the opposite side of the parallelogram, and we have already seen here parallel translation of the vector does not bring any change in it. That's why we have parallelly translate this vector here. Now the angle between AB vector or A vector and B vector is theta, and we have completed the parallelogram. That's why the diagonal AD gives the resultant of the vector. Now we have extended this AB with the dotted lines, and from D we have drawn one perpendicular line. We have dropped one perpendicular line, and the intersected point is E. Now our main task here is to calculate the value of AD. Now in triangle BDE, sin theta is equals to perpendicular divided by hypotenuse, that is DE divided by BD. Therefore DE, where BD, this BD is B, that's why DE will get DE is equals to B sin theta. Again, in the same triangle, cos theta is equals to BE divided by BD. This BE divided by BD, hence BE, we can get BE is equals to B cos theta. Now again, we come here in triangle ADE. In triangle ADE, using Pythagoras theorem, AD square is equals to AE, where AE is AB plus BE. That's why AB plus BE whole square plus DE whole square. Now we will substitute the value of BE and DE from there, and B cos theta we put the value of B as B cos theta and value of D as B sin theta. That's why we will get such type of the expression, and simplifying this expression we will get this result: A square plus 2AB cos theta plus B square. Therefore this one is AD square. Therefore magnitude of A vector plus B vector is equals to AD, can be given as root under A square plus B square plus 2AB cos theta. Okay, again, the angle of the resultant vector with A vector is alpha. Here this is the resultant, AD is the resultant vector, and this resultant vector with respect to this A vector makes an angle alpha. Then from triangle ADE, tan alpha will be perpendicular divided by base. That's why tan alpha is equals to DE, which is perpendicular, and base is equals to AE, which has the parts AB plus BE. And putting the value of DE and BE again from there, we'll get tan alpha is equals to B sin theta divided by A plus B cos theta. Okay, now let us do one example, and the example is there are two vectors of equal magnitude A making angle theta with each other. Find the magnitude of the resultant and the direction of the resultant. The concept of the problem is there are two vectors. Let us suppose the two vectors be xy and xz vector, both has the equal magnitude, and the angle between the vectors is theta. Now the magnitude can be given as, by using this rule, root under A vector magnitude, that means A square, B vector magnitude has the same magnitude, plus 2AB, A also has A, B also has A, that's why A square cos theta. Here we will get 2A square plus 2a square cos theta is equals to this 2a square will come out as common, 1 plus cos theta. We can write 1 plus cos theta as 2a square, 1 plus cos theta is 2 cos square theta by 2 is equals to root under 4a square cos square theta by 2. Finally, we will get the result 2a cos theta by 2. Now, the direction of resultant can be given as tan alpha is equals to, the formula is b sin theta divided by a plus b cos theta. B sin theta, b is a, and sin theta can be written as 2 sin theta by 2 dot cos theta by 2, and here a plus this b also as the magnitude a cos theta is equals to 2a sin theta by 2 dot cos theta by 2 divided by a 1 plus cos theta is equals to 2a sin theta by 2 dot cos theta by 2 divided by a, this 1 plus cos theta can be written as 2 cos square theta by 2. Here this cos theta, this 2 cos square cancels, this a cancel, is equals to 10 theta by 2. Therefore, tan alpha is equals to tan theta by 2, or alpha is equals to theta by 2. Here we come to the very important conclusion that alpha is equals to theta by 2. This suggests that whenever there are two vectors of equal magnitude, then the resultant vector will bisect the vectors. That means the resultant vector will bisect the two vectors.